Hello, Ibrahim. Good morning.
Hello, ma'am. Good morning. Sorry, I'm late.
Okay, how was your maths exam yesterday?
Ma'am, it went good. Thank you.
It was good. Okay, that's good to hear. Okay, Abraham, I was thinking, um, I can revise your science with you right now for tomorrow's paper. Anything you want to revise in science? Because Emma hasn't joined, so I think I won't be able to start. I won't be starting a new lesson, but I can do science revision.
Okay, ma'am. Just give me 1 minute.
Hmm.
Ma'am, can you do the one with the highest mark? No.
One with the highest mark. What lesson is with the highest mark? Let me just check. Mm, okay, I got it. Your one with the highest marks is matter chapter. This lesson and carbon and its compound acid base salt and force work and energy. Three chapters are there that are your highest marks. Which one do you want me to do? Matter, acid basic salt, carbon and its compounds, work, force and energy.
Ma'am, matter. See, ma'am, carbon and its compounds.
Okay. Carbon and its compounds. About carbon, the things that you have to remember. One, it is an element. It is a non-metal. Okay. And when, or you can say how things get converted into carbon when things such as silk, wood, seeds, hair are put in a test tube and heated. Because they have carbon in them, they get converted into carbon. Okay. Now, carbon dioxide in air is there, biogas, petroleum, coal, etc. Okay, carbon dioxide is there. They have like carbon in them, And the allotropes of carbon can be crystalline or amorphous. I explained this to you last time. Tell me what is the meaning of this? Allotrope.
Like different kinds of carbon.
Different physical forms. Physical forms. Crystal or amorphous. Okay. No definite shape. Okay, allotropes means the different physical forms of carbon can be in crystalline form, or it is possible that it has or can be amorphous, means having no definite shape. Okay. Now there is examples. Okay, diamond, graphite, and fullerenes. Okay, diamond, graphite, and fullerenes are crystalline allotropes, means crystalline type of or crystalline form of carbon. But coke, coal, which is mineral form of coal, is the amorphous allotrope, means it does not have a definite shape. It does not have a definite shape. Coke, coal does not have a definite shape. These are the examples. Okay. What compounds are made up of carbon? Carbon dioxide and methane. Okay. Various applications of carbon are there. Various applications of carbon dioxide, and methane are there in industries. Okay. Now, diamonds are there. You know about diamonds. They were formed millions of years back due to high pressure, due to which crystallization of carbon took place. Carbon, when it is there in the ground, okay, and like fossil fuels, when high pressure is there applied, okay, over the years, that carbon becomes crystal, okay, change in its form takes place and it becomes crystal form, okay, that is known as crystallization. Now, pure diamond is very hard, bad conductor of electricity. When it is heated at a very high temperature, carbon dioxide comes out of it. Acids and alkalis do not have any effect on diamonds. Acids and alkalis do not have any effect on diamonds. Now, the uses of carbon used for cutting glass ornaments. Okay. If pure diamond we put it under very high pressure, at a very high temperature, artificial diamonds are formed, also known as AD. Artificial diamonds are formed, which are used to make jewelry and ornaments. Okay. Graphite. Crystalline form of graphite is hexagonal. It is found in nature is soft, black, and slippery. It is a good conductor of electricity and heat. Graphite is opposite. Okay. Diamond is hard. Graphite is soft, black, slippery, and it is a good conductor of heat and electricity. What are its uses? It's used in pencils and as a lubricant. It is also used in batteries as a positive electrode. If you've opened a cell, that gray color stick is there na, inside. That is graphite. Okay. Graphite is also used in arc lights. Carbon dioxide. It is present in air in a free state, means free state. Okay, it is present in air because it is a gas. It is given out by animals and plants during breathing. Now, carbon dioxide in compound form is found in chalk, tiles, limestone. We studied the chemical reaction of limestone, how it uses carbon dioxide, right? So, carbon dioxide is present in these things in compound form. What are the physical properties of CO2? 1, it is colorless. 2, it is tasteless. 3, it is odorless. Okay, and it is heavier than air. It dissolves partially in water. These are the physical properties of CO2. Chemical properties. When carbon dioxide is passed through lime water, it turns it milky. Okay, this was the reaction. What are the uses of carbon? Making cold drinks, making dry ice, fire extinguishers, making washing soda, making sodium bicarbonate, that is soda. Plants use CO2 to make their food. These are all the uses of carbon. Okay. Production of methane. In gobar gas plants, animals and plant waste are put in absence of air in order to produce methane gas. In nature, methane is found in marshy places. Okay, means only some places they are found which have a denser, you can say, environment or climate. Methane cannot be liquefied by putting pressure. So it cannot be filled in cylinders, but it is carried through pipes. When burnt in air, methane burns in a blue flame. It is an important natural fuel. Abraham, are you here? Are you able to hear my voice properly?
Yes, ma'am.
Yes. Okay. Uses of methane are used as a fuel and also in the production of carbon compound named acetylene. Okay. In the production of a carbon compound called acetylene, we use methane gas. So this was about carbon and its compounds, Abraham. Okay. The compounds are diamond, graphite, CO2, and everything that we studied. Okay, carbon is an element. Okay, and all of these are its compounds. Okay. Hope this was clear. From here you have acid, bases, and salt. And I know that for you this chapter is clear. Like from this part, acid, bases, and salt is clear.
Ma'am, the
Yes.
energy now. Energy.
Energy. This one, force, work, and energy. We know that force. What is force? Yeah.
Ma'am, energy because I'm not like I understand it, ma'am, but I want a little bit clear. Uh,
A little bit clear. Energy, according to your book, is the capacity to do a work. Okay. The capacity means how much capacity do we have to do a particular task is called energy. Okay, if I give you an example, there are two people. And I told them both of them, to do 100 jumps. Okay, 100 jumps. Now one person does 100 jumps. Both of them started at the same time to do 100 jumps. Okay, one person was able to do 60 jumps and the other person was able to do 95 jumps. Okay, one person was able to do 60 jumps and other one was able to do 95 jumps. Okay, now jump is also the same type of jump. There are different types of jumps: slow jump, high jump. So that jump was also same type of jump, but this person, the first person who was able to do only 60 jumps is because he has only that much capacity or energy to do jumps. Whereas this other person did 95 jumps because he has higher capacity to do jump. Okay, higher energy to do jump. So that is known as capacity. This thing is known as capacity, that how much can you do, how much of the energy you have to do something, okay, or the capacity to do a work is called energy. Okay, understood energy?
Yes, ma'am. Thank you.
Okay, so what definitions you want from me in particular, Abraham? I'll send it today.
Ma'am, can I have the definitions of because the definitions of almost all the important stuff as the ones you think are important, ma'am.
Hmm.
That's all I want, ma'am.
Okay, I will send it to you today. All the stuff that I think is important. Today is a social science paper, right?
No, ma'am. Today is my birthday.
Today is your.
Bakery, ma'am. I don't do social science.
Okay. Okay, right. Hmm. Okay, Abraham. 5 minutes break for you, and then we will start with maths. Hello, Joshua. Good morning. Okay, Abraham and Joshua, we will start now. Can you hear me?
Yes, ma'am. Hi, ma'am. Good morning, ma'am.
Good morning. Videos on, please.
Yes, ma'am. Can you just give me a minute, ma'am?
Hmm. Yesterday we were talking about medians and altitudes. Okay. Medians and altitudes of a triangle. Today we will check out something new. Okay. I'm starting now. Now, in a triangle, there are three angles. Okay, we discussed about that. That in a triangle there are three angles. Okay, what is their total or what is their sum? When we add them all up, their sum is equals to 180 degree. Okay, their sum is equals to 180 degree. Okay, say I have this triangle. One second. Now this triangle ABC, which has three angles, angle 1, 2 and 3. Okay, angle 1, 2 and 3. Okay, now what the rule says is all angles are equal to 180 degree. That is angle A plus angle B plus angle C. When I add them all, they are equal to 180 degree. Okay, for this, one verification is there. Verification is there. Okay, but how to verify? How to verify that all angles add up to 180 degree in a triangle? How to verify that? Okay, now for this verification, we will draw a line here passing through A. Okay, parallel to BC. We will draw a line parallel to BC, passing through A point. Okay, now the other angles that are formed around A, I will name them also. Okay, these are 1, 2, 3. I will name them this one, this angle and this angle, 4 and 5, 4 and 5. Okay, so when you take a look at this figure, we can say that angle 2 is equals to angle 4, means that this inside angle is equals to this angle. Why? They are alternate angles. Alternate angles. In the same way, this inside angle is equal to this outside angle. Why? Alternate angles. Angle 3 is equals to angle 5. Alternate angles. And 1, see, 1 is coming. 1 is coming in this part also with the external angles, and in this part also with the internal angles. Okay, what am I trying to say? What am I trying to say? 1 is coming with 4 and 5 here also. Okay, and 1 is coming with 2 and 3 inside also. Okay, so you can write as angle 1 is equals to angle 1, common to both. Common to both. Okay, now what will happen? What will happen? When we add these two sides mentioned separately, okay? When we add these two sides mentioned separately, adding sides mentioned separately, we will get angle 2 plus 1 plus 3 is equals to angle 4 plus angle 1 plus angle 5. Okay, so I can say that when angle 2 plus angle 1 plus angle 3 equals to 180 degree. So because this whole thing is 180, this whole thing is 180. Okay, were you able to understand or not? No, right? I will explain it to you once more. Okay, look very carefully. Abraham, video on. Look very carefully. What we are doing is that these three are on a straight line. These three angles are on a straight line, and angles on a straight line is equals to 180 degree. Okay, angles on a straight line are equal to 180 degree. We are proving that these angles on the inside, that is 2, 3 and 1, 2 and 3 are also 180 degree. Why? Because 2 is equals to 4. Because this 2 is equals to 4. Okay, same. Why? Because they are alternate angles. Okay. And also this 5 is equals to 3. Why? Alternate angles. They are like this now. Like angles which are made. Here is a transversal. Here is one angle made and here is one angle made. They are equal. Okay.
Am I
So,
understood?
yes. So, and one is same. One is same in both. The above one also 3 lines and the inside triangle also. So since those three, since 4 is equal to 2, 3 is equal to 5, and 1 is common, I can write it like 1 plus 2 plus 3. Inside 1 is equals to 4 plus 1 plus 5. Because 4 plus 1 plus 5 is 180, 1, 2 and 3 is also 180. That is how it is verified that the sum of all three angles of a triangle is equal to 180 degree. That is how we say that sum of all angles of a triangle is equal to 180 degree. Joshua understood or not?
Yes, ma'am.
Yes. Okay, write this down. Verification.
Should we make the diagram, ma'am?
Yes, you have to make the diagram also.
Done, ma'am. I copied and I understood it very well. Thank you.
Okay. We will do some questions after this to in which you have to find out the angles in a triangle. Okay.
Done, ma'am.
Okay, Joshua. Okay. Take a look at this triangle. Find out angle Q and tell me what is angle Q. Find angle Q and tell me.
$75, ma'am.
75. Okay. One second. Angle Q, Joshua.
Ma'am, can I say, ma'am?
Yes, Abraham.
Ma'am, I think it's 105 degrees.
It's
Just
150 degrees. Joshua has added them. Okay, Joshua halfway correct. 75 you have to subtract now from 180. Okay. The 75 you got, you minus that from 180. 30.
Okay, ma'am.
30 plus Q plus 45 equals to 180. 30 plus 45, 75 plus Q equals to 180. Angle Q is equals to 180 minus 75. 105 degree. 105 degree. Okay. Now, write this, make the diagram. Okay. Write this, make the diagram. After this, we'll check out a ratio question. Handwriting?
And
Now, sometimes you are given that angle 1 is, angle 1, 2, and 3 are in the ratio of 1, 2, and 3. Basically, means that three angles are in the ratio of 1, 2, and 3, or any number 5, 6, 7. Okay, 2, 3, 4. Okay, that time how to solve it, we will see. Okay,
Yes, I
suppose your question is like this: ratio of the angles of a triangle is 1:2:3. Okay, find the measure of all angles. Find the measure of all angles. Now, questions like this are very simple. Okay, questions like this are very easy. Why? Because these 1, 2, and 3, now you assume them as whatever the ratio is, assume them as, put an x behind it. Assume it as 1x, 2x, 3x. Okay, equals to 180. So that is our equation. That will be our equation. 1x, okay, plus 2x plus 3x. Just put an x behind the numbers. Equals to 180. Equals to 180. Okay, now solve it. 3 plus 2, 4 plus 1. 3 plus 2, 5 plus 1, 6x. Okay, 6x is equals to 180. Write it. 6x is equals to 180.
divide 180 by 6. That will give you the answer.
Yes. 180 divided by 6. 6 will go here. Yes, Abraham. 30. 30 is my x. Now, ma'am, this is only one angle. This is only one angle. What about 1, 2, and 3? Okay, now here is also a very easy part. 1x means that
The angle
angle 1 is equals to 30. Okay, angle 2 is 2x. Okay, so for angle 2, you do 2x. Means that 2 into x. That is 2 into 30, 60. Angle 3, you do 3x. 3x means 3 into x. 3 into 30. How much? 90. Okay, how much? 90. So this x that you get, okay, first you multiply it with this number, then you multiply it with this number, then you multiply it with this number. This x you are going to multiply with 1, with 2 and 3 to get all your angles. Okay, this is very easy. You multiply it with 1, 2 and 3 to get all three of your angles. First, so you just put an x behind them. Okay, whatever the numbers. Suppose if ratio is in 4, 5, 4 is to 5 is to 6. What it becomes? 4x plus 5x plus 6x is equals to 180. Add them and divide it by 180. Add them together. Divide that number by 180. Divide 180 by that number. Okay. Divide 180 by that number. You will get x. Now multiply the value of x with 4. X into 4, x into 5, x into 6. You will get all the three angles. Easy? Yes. So whenever ratio question comes, you have to do it like this. Okay. Whenever ratio question comes, you have to just do it like this. I'm going to give you one ratio question now. Okay. Let me just clear it. Three angles of a triangle are in the ratio 8:9 is to, just write 7:8:9. Find their measure. Find their measure. Solve this step by step. Solve it in your notebook step by step and tell me what is the measure. Your answer may come in points, okay? It is not wrong. If it also comes in points, it will not be wrong. Okay?
Pardon, ma'am, I didn't hear the last part, ma'am.
I'm saying that the answer can also come in points in this question. Okay?
Okay, ma'am. Thank you, ma'am.
Solve this.
Ma'am, the
Yeah.
answer is the first one is what you call it? The first one is 52.5. Second one is 60. Okay, ma'am.
Hmm.
I got lost.
60 and 67.5.
Correct. All three answers are correct, Abraham. Joshua, what are you getting?
Same answers, ma'am.
Same answers. Very good. Very good. Both
But
of
I
you.
got a little lower.
You cannot see it lower. Okay. 7x, 8x, 9x, 180, 24x, 180. X is equals to by 24. X is 7 points. How much? Joshua, how much?
Pardon,
24.
ma'am?
180 divided by 24. How much did you get?
180 divided by 25 got 7.5.
7.5. Now we'll find out the other angles. 7x. 7x means 7 into 7.5. Okay, how much? 52.5. Then 8x means 8 into 7.5. How much? 60. 9x. 9 into 7.5. How much? 67.5. So my three angles are 52.5, 60, and 67.5. This is the answer. Well done, both of you. Now, for the homework, I want you to complete till exercise 7.3. Okay. I want you to complete till exercise 7.3. 7.2 was homework for yesterday. Fill in the blanks are there only. 7.3 is homework for today. Okay, understood? Maths test 9.4 to 9.6 is this Friday, day after tomorrow. Okay, 7.4 to 7.6 is day after tomorrow. All right. Okay. Okay, then. See you both tomorrow. Have a good day. Bye.
Bye, ma'am. Thank you, ma'am. Bye, Abraham.